Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
Well, thanks, folks, for sticking around. I hope I didn't chase away too many people with the first talk. And by the way, for those of you that didn't make part one, it's not a prerequisite. You didn't necessarily miss anything. The two presentations are separate. But what we did in the presentation that was in this room before was kind of a whirlwind tour of a half dozen to a dozen visualization libraries in JavaScript that lets you do data visualization in a browser. And I think the thing that was most conspicuous about the libraries that we looked at in part one is what we didn't look at, which is kind of the elephant in the room. If any of you have heard of a data visualization library in JavaScript, you've probably heard of D3. And we didn't talk about D3 in the first presentation. Excuse me. Part of the reason for that is I wanted to keep part one to be quick and simple. And D3 is probably, it's safe to say, not quick and simple. It does take a little more work, and I think we'll see why in this presentation. But on the other hand, it's an important enough library that it seems it would be wrong to neglect it completely, and that's why I was glad that the organizers were able to find 2 time slots. Just to give you an idea, I don't know if you noticed this, but Kantar yesterday released their awards for Information is Beautiful for 2014, and they have dozens of examples of really wonderful data visualizations. I mean, just to scroll through some of the pictures here. A lot of what they awards are based on are print or posters and such, so that it's not strictly web-based. In fact, most of it is not web-based. But I did take a look through the websites that they awarded yesterday, just a quick glimpse. And half of those websites were using D3 to do their visualizations. The ones that were not using D3, none of them used any library in common. So D3 was used on half of the websites. The next most common library was used on one of the websites. So I think it does give you an idea of how important D3 is for data visualizations. And if you're not familiar with the history of D3, it was developed by Mike Bostock, who is the head of the online graphics department at the New York Times. So if you've spent any web browsing time on the New York Times website and you've marveled at the wonderful visualizations that the New York Times graphics department creates, in general they are all created using D3. And it's not just the New York Times. Mike was generous enough to open source the library. So it is, as you can see, used all over the place on the internet. But it is a bit of a different beast. So I thought what we do today is take at least a little bit of a deep dive. In an hour, it's not really possible to give a D3 tutorial. A real tutorial would probably take, I would think, 2 days. So it would be a 2-day workshop because it's really that powerful a library. But at least by walking through some examples, I'd like to give you folks a flavor of D3 and sort of an understanding of the philosophy behind it, so that if you want to dig in a little deeper, either on the web or there's, I think, last count on Amazon, there are 5 or 6 books dedicated to D3. You'll at least have a flavor of it from this talk, so you won't be quite so surprised when you dig into it later if you're interested. The way I thought we'd do the D3 example is to take a graph that we looked at in my first talk. And don't worry if you missed the first talk, it's not all that important. But it is a network graph. And the network graph shows the top 25 jazz albums of all time, at least according to one blogger. And the links between those albums are musicians that are common to multiple albums. So, John Coltrane, for example, appears on several of the albums in the top 25. So those albums will be linked together with John Coltrane as a musician in common. And that's a static picture, but just to show you, this is the resulting picture live on a web page, and it is interactive. You can look at the connections. The one in the center here is Miles Davis, Kind of Blue. It's all the musicians on that album or on many of the other top 25. When we did this visualization in the first session, we used a Sigma.js as a third-party library. And as I think you'll have to agree if you saw it, it's very simple to do with Sigma.js. You just start with your data, you throw your data into the library's API, and maybe you turn on force direction to get it to lay out the nodes for you, and you're done. It's piece of cake simple. It won't be quite that easy with D3, but what we will be able to do with D3 is have a lot more control over the graph. In particular, I'll just show you what we're going to end up with when we complete. Unfortunately, it won't. The screen is so small it doesn't show up. Won't fit on the screen here. But this is the visualization in D3. Again, it's a network graph. You can click on Kind of Blue, and you'll notice that we see the album, the musicians on the album over here. Things like the transition. If you notice that the radius of the circle is a nice animation. Lots of things we can do with D3 to make the graph a lot more appealing than the relatively simple network graph that we created with Sigma.js. I think the place to start with in D3 is to at least understand a little bit about the philosophy behind it. And I think one of the things that some people will find is surprising is that D3, I would say it's not really a data visualization library. And that may sound funny, and it's certainly not, it doesn't seem consistent with the reputation it has. But it is certainly different from all of the other visualization libraries that certainly the ones we talked about before, and that D3 doesn't draw visualization for you. We talked in the first section whether you want to use SVG or Canvas or HTML. D3 doesn't do any of those for you. What D3 really is sort of given by its name, and D3 stands for Data-Driven Documents. And what it is it's a way of associating data with DOM elements and managing that association. It doesn't do any drawing, and I think I'll probably emphasize that a few times, and I think you'll see it when we go through the example. The D3 is not going to draw anything for you, but it will manage the data so that you can do the drawing that you want to do on your visualization. I think maybe the analogy that I like to use when I compare D3 to more traditional visualization libraries is shopping for a new home. A traditional library is kind of like the traditional way you might look for a new home. Right? You find a real estate agent. The real estate agent would take you around, show you different homes. You'd find one you like. I like that. Go purchase the home, and then when you move in, you can rearrange the furniture, repaint the walls, but you've pretty much got the home that you want that the real estate agent showed you. If you're going to build a visualization with D3, it's really like shopping for a home at Home Depot. And you can go to Home Depot and they have bricks, right? They've got stucco, they've got wood framing, you need plumbing, they got plumbing supplies, electricity, electrical wiring, appliances, right? You can buy everything you need for your new home at Home Depot. And of course you're also going to need tools, right? You're going to have to weld your plumbing things, you're going to have to saw your framing. So yeah, you can buy saws and welding torches and all that other stuff at Home Depot. And that's really kind of what building a visualization with D3 is. You're not going to get a pre-built home, but you've got all the tools that you need and all the materials that you need that you can put together in whatever way you want. And typically it's for a custom visualization. What I think is interesting is there are lots of third-party libraries that do like charts, and they advertise the fact that we use D3, and I'm like, well, so what? If you just want to build a chart, just because there's D3 buried under the hood doesn't make it any better of a chart than what you'd get from JQplot or Plotter or HiCharts or anything like that. So I'm a little bit amused by people that take D3, which is a custom library, and then try to cover up all that customization and just turn it into your standard charting library. That just, to me, it doesn't make sense at all. If you're going to do standard charts, use a standard charting library. If you need custom, that's when you pull out D3. So here we'll start with how we're going to build our network graph that connects the top 25 jazz albums of all time. And not anything surprising. We'll start with an HTML skeleton, and we'll create a container for our graph. And then in the example that we have, actually, I'm going to use two divs, one for the graph itself with the ID of graph, and a separate container for the notes, the album cover, and it's got a link to iTunes and the musicians and stuff. And then we need to include d3.js, the library itself. I think it's worth noting that D3 is intended as the only library that you need for visualizations, and that goes back to probably the philosophy of Mike Bostock, the creator. I guess you would say that Mike is definitely a not invented here kind of guy, because D3 even has its own tools for doing unit tests, right? It's like, I don't want to use anything from anybody else. So the D3 is intended to be the only library that you need. Now that doesn't mean you can't use it with things like jQuery or Backbone or Angular. You certainly can, and there are even plugins that, there's an Angular plugin, I think there's a React plugin for D3. But that's a little bit of a square peg round hole. If you look at what D3 is intended, it's intended to be the only library you need on a web page where you're doing visualizations. So, of course, if we're going to visualize data, we do have to have some data to visualize. This is the data that we might get in JSON format for our jazz albums. The artist, the primary artist, the title, musicians, and then there's some other things that we might use to add information to the visualization, like there's an iTunes link and a URL for the cover image and stuff. So of course, you could embed that in your JavaScript, but more likely you're going to want to store that kind of data in general for a visualization. It's probably going to be in a separate file. And as I said, D3 intends to be everything you need. So one of the things it can do is handle AJAX requests. So D3 has a very complete library, just like jQuery does for AJAX. D3 has its own library for all the AJAX handling that at least Mike Bostock thinks you need for visualizations. So right from the start, we know we don't need traditional jQuery type stuff. We can go with D3, and it'll fetch the data using AJAX. It has support for not just JSON, but as you would expect for a visualization library, things like comma-separated values and tab-separated values and such as well. Once we have our data, we do need to kind of massage it into a structure that D3 can deal with. And for a force-directed graph, as we'll see, D3 has some really nice things that will help us create that graph. It's the tools that I mentioned earlier. It's got the welding arc, the welding torches and the saws and stuff. And those tools work pretty well if data has a particular format. And the format for force direction is really two different arrays. One array containing all the nodes that are in the graph, and a separate array that contains all the links or edges between the node. So once we've fetched the data using JSON within that callback, what we'll do is take that data and create an array of nodes that we'll use. We'll give it to D3 to help us create the graph. A couple of things that are worth noting right from the start here. We are going to, just as we did with Sigma.js, when we create the graph to start with, we need at least a starting point to place those nodes on the web page. We've got to put them somewhere when we draw them the first time. And since we don't have thousands of nodes, we're just dealing with 25 in this case, a convenient way to lay them out initially is to just put them in a circle around the region. So what we're going to do, the bottom section of this code block, is we're going to calculate where we would put these nodes just in a circle or in the container. And that's just basic trigonometry. We're going to, and they're all going to have the same radius, so they're all the same. So it's a circle, not an ellipse. And then we're just going to take as an angle 1/25, 2/25, 3/25, all the way around the circle. And that's all that we're doing there, is we're calculating an x and a y value for those nodes. So with this code here, we've taken the data that we retrieved via JSON and created an array of nodes for our graph. Next, we want to find all the links between the nodes. And this is just, there are clearly more efficient ways to do this if you have tens of thousands of nodes, but for 25 nodes, we'll just kind of brute force it. Real simple, straightforward. We start with the first album and then iterate through all the musicians on that album, and for each musician, we iterate through all the other albums in the list, and if we find that any of those other albums have that same musician in common, then we create a link for it. Straightforward, but I do want to point out a couple of things. The link, this is really actually hard to do from an angle, manipulate the mouse, but the statement down here where we're actually creating an element in that links array, we're setting two properties of that link, the source and the target. And as you can see from that, the value that we're setting is the index of the source and the index of the target in the nodes array. And I point that out because it's going to be a little bit tricky when we deal with that later, and it's kind of an example of D3JS trying to help us out, but if we're not careful, we have to be aware of how it's helping us out. Now, one of the things that we've done in this code right here is there is certainly the possibility that two albums may have may share multiple musicians. So more than one musician may be in common between the two of the same albums. And with this code, we've created two links, one for each of those musicians. Well, we really don't need two links. We just want to show one link between the albums. So without getting too much detail, we'll go through a third step to eliminate any duplicate links. And otherwise, it's identical. We call these edges to be more technically correct from graph theory. All right, now we've got our data, we've got it all set to go. We can actually start using D3 to create our graph. And here again, I think you'll see that D3 starts to look a lot like a general purpose JavaScript library. It's not something that you add to jQuery. Because one of the things we're going to do is selection, right? We need to select, for example, the div where we want to place the graph. And that's the very first statement there. D3.select is equivalent to jQuery selecting a CSS selector. With one trivial difference. The select function in D3 selects only selects only a single element in the DOM. There's an equivalent function called select all, which actually does what jQuery does. It selects all the matching elements in the DOM. But as you can see, it's like jQuery. It's finding elements in the DOM. We're finding the graph container, we're finding the notes container, and then we're going to actually start drawing the graph. And D3, again, as I said, it doesn't do any drawing for you. So you can draw however method you want. And you can even use D3, I suppose, to create Flash graphics if you wanted to. I think you could make that work. But having said that, D3 is a very natural fit for SVG. Because SVG is so much like HTML, and it's structured like HTML, and you can manipulate it with CSS and JavaScript just like HTML. It would be unusual to use D3 with any rendering technique other than SVG, except maybe for pure HTML. So we're going to use SVG to render our network graph. And you can see that what we're doing there looks a lot like jQuery, right? We've got the graph container, we're appending an SVG element, and we're setting the attributes of that element to width and height. And that, again, it is D3 intending to be a full-featured JavaScript library. You don't need jQuery or any equivalent to do everything you'd need for the visualization. Well, now that you know that, now that you can see that adding an element to the DOM with D3 is just a matter of appending something, you might think, well, if we're going to draw our nodes, and again, there are 25 nodes because there are 25 albums, maybe all we need to do is just append an SVG circle right in the DOM. And that statement that's in the center there does exactly that. It iterates through our nodes array, and for every node, it just appends a circle. That will do what you think it does. It creates 25 circles and puts them on in our DOM. Now, we haven't positioned them yet, but we'll do that shortly. So that does, in fact, draw 25 circles on your web page. And it would work, but it's not really using D3 as D3 is intended to be used. And the different approach is something that looks a little funky at first. In fact, it looks not more than a little funky. It looks quite weird if you've never seen it before. But this is how we would start the process of drawing the nodes using D3 as it's intended to be used. So what's going on here? We're defining a variable called selection. And what we're doing with that variable is we're selecting all of the circle elements in the graph and then calling this data method on those elements. Now, the reason that looks kind of funny is we just started out, we don't have any circle elements in the graph. Right? All we've done so far is we've fetched the data and we've organized it into arrays, but we haven't started drawing. All we've done is created the SVG element. So you would think that calling select all circle would end up with an empty set. And what would you do with an empty set? Well, your first thought is right. Select all circle does result in an empty set because there are no circles in the DOM at this point. But it turns out that doesn't matter, and that's not important because of what we're doing with that selection. And what we're doing with that selection is in the data method. And that data method says, okay, D3, I'm telling you what I want to happen. I want every circle in my graph to be associated one-to-one with a node, or in our case, a node is an album. Now, maybe the way to understand it is imagine what would happen if the circles did exist in the DOM. If we did have 25, or to make it simple, let's say there are only 4 albums. Well, what would happen if we executed that select all circle data nodes and there were 4 circles in our graph and 4 albums that we were visualizing? What D3 will do is go find each circle and go find a node from our data set and associate the two together. So we'll say I've got a circle, which is an element in the DOM, and I've got a node, which is an element in my data set, and I'm going to marry those two together and manage that association. So if we did that with 4 circles and 4 albums, the result would be a selection, because we're storing this in the variable selection, that had 4 objects in it. And each of those objects would be an association between a DOM element and a data object. So that's what would happen if those circles existed. Well, what happens if only some of the circles existed? Well, D3 would still do exactly the same thing, except those last 2 data objects wouldn't have a circle. They'd be lonely, right? It would go, D3 will find all the circles that are in our graph. It would find, in this example, 2 of them, and then it would start matching them to our data. And the first 2 data objects, there would be a circle that matches, and so D3 would say, okay, got you. Second one, I got you. When you got to the third one, it would say, uh-oh, there's no circle left. I don't have any circle in the DOM, but I've got data because there are 4 albums in my data set. So it would still create the same object, but it would just note that there happens to not be a circle associated with this object. But the key is you still end up with a selection of 4 objects. And each of those objects is an association between a DOM element, if it exists, and a data object, or an object in our data set. And as you can guess, even if there are no circles, D3 does the same thing. It's just sort of the extreme case of the previous example. It's still going to create 4 objects. So that SVG select all circle, there are no circles to be found, but when it tries to associate data with them, it will end up creating 4 objects for us. It's just each of those objects will not have a DOM element associated with it. That definitely throws off a lot of folks when they first come to D3, and it's probably one of the hardest concepts to get over. But if you understand that, and maybe it takes a couple of walking through some examples on your own to get it, then D3 starts to make a lot of sense. Once you've done that selection statement, once you've created that selection variable, then we're going to draw the actual circles. And we do that with the second statement there, or you can see the more concise and more typical coding style. We call selection, again, the selection is that array of 4 objects. We use the enter method, and then we append a circle. Now what the enter method returns is a subset of the selection. And in particular, it returns the subset of the selection that doesn't have any DOM elements associated with it. Well, in our case, that's the entire, when we start off, that's the entire data set, because we don't have any circles. So all of our data objects don't have a DOM element associated with it. So when we do a selection enter, it's going to return, in our case, 25, all 25 objects representing all 25 nodes. And then for each of those 25 objects, we append a circle. And that sticks the circle in the DOM. I mean, I'm not even moving. Maybe it's getting close to Halloween. So that is the way, using the more typical D3 convention, that we create DOM elements corresponding to our data. Question?
SVG is a D3 object?
SVG, yes. To back up, SVG is the D3 object that was returned in the third statement there when we appended SVG to the graph container. And that's actually, I'm glad you brought that up, because that's another different, something that's slightly different with D3 from a more typical library like jQuery. With jQuery, right, you could have a container append an SVG, and the append function, the append method in jQuery, it returns the same parent object that you started with. So in jQuery, graph append SVG would return the graph container. In D3, the append method returns the appended object and not the parent. So it's different from jQuery, but what graph.append returns is the appended SVG element. And so then when we get to this statement there, we start with that SVG element, we select all the circles, we marry it with the data, and then in the second statement, we go find anything in that selection that doesn't have a DOM element with it and append a circle corresponding to that data. That's what it takes to draw the circles. Kind of the same approach is what we use to draw the edges or the connections between the graphs. Again, we're going to create a variable that will store that selection. We're going to select all the lines, all the SVG line tags in the DOM. There won't be any when we start off with. We're going to associate all those potential lines with data objects. So there'll be as many of those objects as there are edges in our data set. And then for every one of those objects that doesn't yet have a line, we're going to create one and append it to the container. And I made a note here, actually we would draw the edges before we draw the nodes, and that's just because of the way SVG works. SVG doesn't really have the concept of z-index like HTML does, so you can't arbitrarily stack objects on top of each other. The way SVG renders it is whatever shows up first is on the bottom, and we really want the edges to be underneath the nodes, so technically we would draw the edges before we would draw the nodes, but kind of a minor detail. I think it's easier to explain the nodes first. Now what we have to do is we've added a bunch of HTML or SVG tags to our web page, but we haven't positioned them anywhere yet, so they're just kind of arbitrary. We want to position them. And remember, we started off when we created that node array, we set the X and Y properties of each node to be a circle around the periphery of our container. So now we'll go ahead and just using standard SVG attributes, we'll position the nodes. We'll give each a radius of 10 pixels. And then we'll set the CX and CY, which in SVG for circles is center X and center Y. So it's the coordinates of the center of the circle. And you notice that when we set the attribute, instead of giving it a value like 10 as we did for the radius, we provide a function. And this is where D3 gets really sweet, because what D3 will do when it sees a function where you might normally pass a value is it will call that function with the data object corresponding to that particular DOM element. So it's going to go around through all of our nodes. Sounds like I just lost. Maybe I'll have to shout. At least we're not hearing the grumble anymore, right? So it's going to go around to each of the nodes, and for each node, we're going to tell it to set the X and Y of the center of that node based on the X and Y properties that we defined for each node separately. And as you can see, that data value that will be the node that we created in our array. Similarly, for the edges, we need to position the X1, Y1, and X2, Y2 of each edge. And we're just going to put each edge right at the center of the corresponding nodes. And D3, when we set up the edges, we provided the index of the source and target nodes, so we can access our nodes array using that index and then get the X and Y properties that correspond to that node and use those to position the edge. So at this point, we've added the node circles to our web page, and we've added the edge lines to our web page, and now we've gone through and set the attributes, the radius and the X and Y coordinates of all of those elements, so that we've positioned the nodes, at least in their starting place, on the graph. And I'm sorry that the screen distortion makes that a little hard to read, but at that point, if we stopped and did nothing else, we would have this graph to the extent that you can see it. So you can see we've got 25 nodes corresponding to our albums. They're all arranged in a circle on the page, and any albums that have a musician in common have a line connecting them. All right, as we talked about in the previous hour, that's okay for a static position, but if you look at it, even if you could see it clearly, a lot of those nodes are kind of jumbled together, and it's a little hard to separate, visually separate which nodes are which, and see how they're connected. So one of the things we can do with D3, just as we did with Sigma.js, is use a force direction algorithm that will rearrange and reposition the nodes in a more visually pleasing arrangement. You got a battery?
I'll bring it back to you in a minute. It looks like it's on though. Testing.
Right. The algorithm that does that, and actually it's not just one algorithm, it's a set of algorithms, are called force direction algorithms. And for those of you that weren't here in the previous hour, a force direction algorithm, in a nutshell, it assumes that these objects are real physical objects. It pretends that these are things that have real mass and real electrical charge, and then it says, let's, the heck with it, let's just, what happens if we have objects with real mass and real electric charge, and we subject them to electromagnetic forces and gravitational forces, and they're going to move around, and let's just move our nodes around in a corresponding way. So it simulates a physical world, and typically you'll see force direction simulates both gravity and electromagnetism. Gravity is a way to keep the nodes from flying off the page because it's an attractive force. And electromagnetism is a repulsive force. It assumes they all have the same charge, so that kind of forces the nodes apart so they don't land on top of each other. D3 has this nice little helper, it's called a layout, that does force direction for us. And this is how we would initialize that D3 object. It's called a force layout. As you see, D3 layout force, we tell it the size so it knows what the boundary of the graph is. We give it the array of nodes, and we give it the array of edges, and then we give it a few parameters. As with the case with Sigma.js, the best way typically to find the good parameters for this is trial and error, because even though, they have sort of physical meaning in the sense that there's charge and there's gravitational force, it's virtually impossible to kind of anticipate what that's going to do on a real graph. So you really have to do trial and error. And this trial and error, the two parameters that in this example we're setting, we set a desired link distance, and this is telling D3 that we'd like nodes that are connected with each other to end up about 40 pixels apart, maybe a little further, maybe a little closer, but try to keep it within 40 pixels more or less. And then force is the electromagnetic repulsive force that each particle or each node will have in the force direction. D3 has a bunch of other parameters too. These are just two. It's got about 7 or 8 parameters for the force layout. It turns out that for this example, the default values are fine for all of those other parameters. But if you want, you can certainly look at the other parameters and see how to adjust things like gravitational force and spring constants and such. Again, start with the defaults and just sort of play around is my best advice for coming up with a good approach for a particular visualization. Now, once we've got this force layout defined, what D3 is going to do is it's going to start simulating the passage of time. As gravitation and electromagnetism acts on these particles as time advances. And it will call a handler that we provide at every tick of time. So D3 is going to run for a simulated period of time. It's kind of arbitrary, but let's say it's a second. And after a second, it will call our function and say, okay, after a second, the forces have moved the nodes and the edges this way. Here's the new data for you. And then it will continue to increment until it stabilizes. So we'll want to, this is actually optional. You don't have to do this. But if you want to show the nodes as they move under the direction of this force layout, we'll set up a handler to deal with every tick of the clock. And at each tick, all we need to do is reposition the nodes. And what the D3 force layout will have done for us is calculate the new positions. So all that complicated math that's necessary for simulating electromagnetism and gravitational forces, D3 handles that all for us. We don't have to mess with it at all. And all it's going to do is update the X and Y properties of our nodes, and it will also, as we'll see, change slightly the source and target properties of our edges. And then, again, D3 is not doing any drawing for us. It's just doing the calculations. It's a tool for us. But once we have the results of that calculation, we have all the information we need to reposition the nodes. So this is what happens at each tick of the simulated force layout. We first are going to position our nodes by setting the center X and center Y of the circles. And all we're going to do is just go grab the X and Y properties, which D3 has conveniently updated for us.
Testing. There it goes. It's working.
Same kind of thing for the edges. And you notice this code looks a lot like what we did when we initially positioned them, but there is an important difference. And maybe you can spot it if I go back. Look at the edge selection, and you can see where we're getting the X and Y values for the edges. We're using an index into the nodes array. After the force layout starts, we don't use an index anymore. We have direct access to the node array. D source and D dot target are the nodes themselves, not the index. And that, I'll be honest, I find that a little confusing. And if I were doing D3, I wouldn't do it that way. But that's the way Mike has done it. He's replaced the indices with references to the actual nodes. Now, I understand why he's doing that. The reason that D3 does that is because D3 assumes that you're probably getting your data from an external data source. So you're probably getting your data from a CSV file or maybe a JSON file or something. And those external data sources don't have references to the actual JavaScript objects that you're going to create because you haven't created them yet. So the only thing that those external data sources will have or could have would be indices into the array. So D3 assumes that, well, if that's all you can have for an external data source, then we'll just run with that. But D3 says, I also recognize that dealing with indices is inconvenient, so I'm going to replace them with a more convenient, the object itself, as soon as I do my first iteration of the force layout. Anyway, it's a bit of a potential confusing point, but it's an example of the kinds of things that D3 does in an attempt to make things as easy as possible. And then finally, once we've set up our handler to handle this tick, we just call start to actually run the force direction layout. And that's almost impossible to see, but I'll show you at least a somewhat reasonable example of what the resulting visualization looks like in a second. One last piece we want to add, though, to this example is some event handling. We'd like the user to be able to click on one of these nodes, and as we saw when I demoed it, have the node change color and show the album cover and a link to iTunes and that kind of stuff. Well, again, this is part of D3 having a philosophy of being a complete library for all your needs. That means it has all the event handling stuff you need. So whereas you might be tempted to use jQuery to add event listeners, you don't need to. D3 has its own event handlers, both for standard JavaScript events as well as custom events. And so this is how we would set up an event handler to deal with users clicking on the nodes. Again, we start with our selection, which is the D3 selection containing all the nodes. Add a handler for the click function. And that click function, all it does is it changes the class. This is really the CSS class of the circle to be selected. And then we can use CSS styling to change the color. And it changes the radius of that circle to be 50% greater than the normal radius. So just multiplies it by 1.5. So that's a really simple D3 event handler, and you can see it does everything you need to handle an event. But you may have noticed that in the example, it wasn't an abrupt change. We actually did a transition or an animation. Well, yes, D3 handles that as well, and it's just that simple. All we need to do is add a transition method call in between, right before we change the attribute. And D3 has very sophisticated and potentially very complex animation handling. I would say it's much more powerful than standard jQuery. jQuery UI, of course, has a lot more animation handling than jQuery proper. But D3 animation is certainly equal to that of jQuery UI and much superior to standard jQuery. And it will use CSS transitions for performance when those are available, but it will fall back to JavaScript transitions if CSS isn't available. So just to refresh your memory, this is the graph, and there you can see how the force layout moved things around when it first loaded, and then eventually it stabilized. And then our click handlers, if we go to any album, we can click on it and we get, the information on the sidebar about the musicians and a link to iTunes and the whole bit. Before I leave you, I want to give you some more information. The source for this example, the one that I just demoed right now, is available on the Mike Bostock has set up a website called blocks.org, and it's a way of taking GIST from GitHub, D3 implementations, and showcasing them. In fact, it's actually, if you want to get into D3, it turns out to be a really handy site in general. And let me show you, you can access it via username, and it will give you all of that user's GISTs that are set up for D3. And you can see these are mine, and there's several of them in there. And if you're interested, for example, in force layout, one of the things that you can see layout 1, layout 2, etc. I did walk through as an example of all the different parameters that D3 supports for force layout. You don't have to copy this necessarily down. I'll give you one link that will get you all the information you need, and that's the second website there, JS Data Viz. That website's available now, and if you go to that website and click on the Talks section, you will find links to all my presentations, including both presentations today, so you can get the links that way. And again, the site is jsdatav.is. And as kind of an extra bonus, I mentioned, you may have seen on the previous slide, I did have a book coming out in early next year on building JavaScript visualizations. And the complete contents for that book are available for free on the website, all of the 9 chapters. So, and that's not going away. That will be there, as long as I keep making payments to my registrar, and don't forget to pay the bill that way. That will be there for you to look in more detail. All the examples that I did both in the earlier session and the example that we just walked through today are in the book in a lot more detail. So feel free to certainly dig in and take a look there. And with that, I'll open it up to questions. Yes?
On the example, can we have a quick event and how he handles selecting the node? How does it handle deselecting of the requirements? Is that automatic, or is that something we have to wire up?
The question was, I think, and let me try to rephrase it, and you can correct me when I go wrong here. D3 allows you to select existing nodes and then through the enter function identify data objects that don't have a DOM element. What about the reverse of that if you have objects in the DOM but no data for them? And that may be the case if your data set is dynamic and you're changing your data set. And if that's the question, the answer is just like there's an enter method, there's an exit method. And the exit method the enter method returns items in your selection that don't have a DOM object. The exit method returns items in your selection that don't have a data object. And the naming for that comes from a stage convention. If you remember, like Snagglepuss from my childhood, enter stage left, exit stage right. So Mike Bostock's idea behind that is data that comes into your stage is entering the stage and it doesn't yet have a DOM element associated with it, so you want to give it one. And then as data is old and is removed from your visualization, it's exiting the stage. So you want to find the DOM elements that correspond to exited data so you can remove those DOM elements from your visualization. And that tends to make dynamic visualizations very easy. As data arrives in your system, you can add it to your DOM very easily, and as data exits your system, you can remove it. Now, did that answer the question?
That was actually my next question, which you answered. What I actually did was, when we were just wiring up the click event, when you wired the click, you set up that you did a select on the element, but we didn't set up it was deselecting all the other, the entire element we made a click. How does that handle?
Yes, and the question was in the example code that I showed on here, we had the code that says when you click on a node, it highlighted the node, but if you observe the behavior of the example, when you clicked on the node, not only does it highlight the node that you clicked on, but it unhighlights whatever you may have clicked on in the past. And no, you do have to wire that up. I just didn't show that code for brevity. Mm-hmm. And by the way, it's worth mentioning, if you look at the examples here, if you scroll down past the actual implementation, this site will show you all the source code. So you can see the full source code for this implementation, and it's, in this case, I tried to do a good job of commenting it. So if you look on the website and you scroll down far enough, you'll see the click handler not only changes the attribute of the selected ones, but also clears the class of the unselected ones too. Mm-hmm.
Earlier you placed all the circles in a circle. Why did we do that instead of just putting them all in one spot and letting them go out from there?
The question was, in the example, I originally placed all the initial placement for the nodes was in a circle around the periphery. And the question is, why do that, and why not just place them all in the center? And there's no reason not to. You can do any of that. I like to explicitly place my nodes somewhere so that I have a consistent visualization. What you can do is you actually don't have to place them anywhere at all. And D3 will place them randomly in the visualization stage. The problem with allowing D3 to place them randomly is when it runs the force layout, there's naturally some randomness associated with that. So if you if you just let D3 place them randomly and you look at a visualization, if you reload the page, it may place them differently, and the resulting visualization could be different. So I like to explicitly place them. That way I know that whenever I run the force layout, I'll get consistent results. And then in terms of why place them in a circle originally, the reason I do that, and it's just a personal preference, is I find it easier to debug. Because if you place them all in the center, they're all kind of on top of each other, and it's a little harder to debug if you've got a problem, whereas if you place them in a circle, then to me at least, it's easier to start debugging and make sure that I've got them in the right place. But there's no reason not to just put them all in the center. And actually most implementations just let D3 randomly place them.
So in dealing with dynamic data, is the best way to handle that and get more data in to just keep calling it .data, just keep passing that whole new data set? So there might be some that exist and some new ones or some that have left. Will it handle properly matching those indexes?
Yes, D3, the question is if your data set is changing, if you have a dynamic data set where you're adding new elements to your data and removing it from that, will D3 track the new elements for you? And absolutely it will. By default, if you don't give it any other hints, the way it tracks that is by indices in the array. So if you start and you fetch 10 data objects and create a visualization, and then you fetch 10 more and append those to the array, then D3 will identify the 10, starting with 11, so 11 through 20, as new elements. And it will, when you call the enter method, it will say, these are new elements, they don't have a DOM element yet, let's draw a circle for them. The problem with doing that, just doing it that way, is if you have elements that are being added and elements that are being deleted, then D3, without any hints, can't tell which ones are added and which ones were deleted. So when you do the data method, you can pass as an optional parameter an index. And that index is a unique value for each data object. So when D3 has that, it will keep track of what data is new and what data is old and no longer there based on the index rather than just its position in the array. I think there was a question a little further back.
Yeah. So D3, how does it render in a mobile device?
The question was, how does it render in mobile devices? I'm not sure of like Android version 2, but certainly Android 4 and on, as well as iOS, have fine support for SVG. so there's no problem using SVG on mobile devices. The performance seems to be fine as well too, so I don't think there's any, I'm not aware of any problem at all using D3 on a mobile device. Now, obviously, if you're building complex visualizations, the visualizations may not work so well on a small screen on a mobile device, but that's not really D3's fault. It's the fact that you have potentially a very complex visualization. Question?
So I had heard that one of the things that was remarkable about D3 was that it's able to handle very large data sets, and it did so in a technical way which allowed, that the client could manage all the memory efficiently. So A, is that true? Is that one of the things that's distinctive about it? And B, what size data sets are we talking about that it can manage really?
And I guess do I need to repeat the question, or did everyone hear it okay? Okay. Yes, D3 does indeed work very well with large data sets. And the reason it actually does that is because it uses the DOM elements to manage those data sets. And so what it's really leveraging there is that browsers are really good at managing large, complex DOM trees. So it's kind of backs into that, but it turns out to be, yes, I would say that's true. I have certainly done visualizations in the past with, I don't think I've quite done 1 million data points on a single web page, but I've certainly done visualizations with several 100,000 data points on a web page. Now, I wouldn't do a forced layout of 100,000 data points because you just end up with a blob, but I've done, for example, histograms where I've done binning over, of like, in the past I've worked in the security industry, and I've looked at graphing security events, in which case could be thousands or tens of thousands per day over a month-long period, and doing binning of those in histograms. And D3 has handled that without any problem. So it seems like 100,000 data points for the right kind of visualization is not a problem. I don't think I've gone up to 1 million though. But that's not saying it wouldn't handle 1 million. Mm-hmm.
I don't know if this exists at all, but are there any other tools that kind of use parts of D3 but not the DOM manipulation stuff, and then maybe rely on like a virtual DOM for diffing or anything like that? I just don't know if there's anything that uses parts of D3 but not the DOM.
Yeah. The question was, do I know of any libraries that would combine D3 with some kind of virtual DOM like React does for high-performance DOM manipulation? And no, I'm not aware of any. It would be fairly challenging to separate the DOM manipulation from D3. It's so core to D3 that I think it would be very challenging to do that. Now, it's open source, so if you wanted to use, for example, D3's forced layout algorithm, you can certainly pull that, and that's isolated enough that you could use a different DOM manipulation thing to do, and just marry that with the forced layout. But I'm not aware of any organized attempt to do that. Well, thanks everyone. Glad to have you.